Hi everybody, my name is Kyle. I'm going to be doing some integrals from the Wolfram Alpha problem generator. So it just generates just random problems that you want. So you have calculus here, you have algebra up top, you have number theory. So I'm just going to be doing the ones with U-Substitution because those are the ones I can actually do in my head. Maybe we can set it up to integration by parts, but it would be harder to keep track of. So this is just a good way to practice if you like to do integrals for fun and just test your skills. So first one, what do we got here? 7/4 sine 7t. Okay, so 1 over 7, 1 over 4. So I'll have 1 over 4 cosine of 7t plus 3. Negative. So it's negative 1 over 4 cosine of 7t plus 3 plus a constant. But I don't think they make us write constants, right? Just doing that in my head. That seems reasonable, right? What? Okay. Am I just not doing it right? Yeah. That's what I have. Oh, add that. Oh, okay, fine. Add the constant of integration. Oh my gosh. Okay, now it was like. See, I knew that was the answer, but like. Gosh. So this is a bit easy. So let's, when we step it up to, let's just do 2 more on the beginner and then we'll go up to intermediate. So 7/2, okay, and then so we'll just get 7 over 10. 7/10 e to the 5t plus, e to the 5t plus 1, right, plus c. Right, one more for the warm-up. And then 2/5, 6t plus 6, okay, so that's just 2 over 30. So 1 over 15 e to the 6t plus 6, 6t plus 6. Okay, plus c. Okay, so now we want to step it up to intermediate. So intermediate, let's just do 3. Okay, integrate 6 to 5 e to the x, e to the x. Ooh. Okay, so let u is equal to ex plus 3. So then, oh yeah, right. So we go. Great. Okay, first the 6/5 outside there. I'm going to think about it. E to the x plus 3, that's going to be my u. So u minus 3 is equal to e to the x, right? So if u is equal to e to the x plus 3, du dx is equal to e to the x dx. Okay, this is actually not that bad. So I have 6/5 u squared. So it's u cubed over 3, so I should get 6 over 15, 6 over 15, right? And we can divide that by a factor of 3, so that's actually 3 over 5, 2 over 5, sorry, 2 over 5 times e to the x, x plus 3 cubed plus c. Oh, see? Okay, not too bad. Took a while, though. Integrate this thing with respect to x. 3, 4x. Okay, just let e to the 4x minus 5 is equal to u. Alright, so then we'll have 4e to the 4x. 4e to the 4x dx is... Okay, wait. Sorry, I know, right? I'm like tripping here. 4e to the 4x. 4. Okay, so 3 over 20. Okay, so I have 3 over 20 as my prefactor. And then I will do so I have u to the minus 1, minus 1, so negative 3 over 20 times, let's see if I get this right, 1 over e to the 4x minus 5, right, plus c. Don't understand my answer, so let's see here. Maybe I should have just written this as negative 3 over 20, down here, 20, 20. I don't know if I have enough parentheses for all these. I think I do. So yeah, let's just try this. Okay, good. See, not too bad. One more of the intermediate, then we go up to advanced. Okay. Sine log 5t plus 6 over 2t. Okay, so this is a trick here. Log of 5t, that'll be my u. So I have log, so u is equal to log 5t. No, u is equal to log 5t plus 6. Du dt is equal to 1 over 5t times 5. So that's 1 over t, right? Just double checking my head. Log of 5t is u du dt is equal to 1 over 5t times 5. So that's just 1 over t dt. So 1 over t dt, and I'm missing a factor of 2. Why don't I just keep the factor of 2 up front, and then I'll have integral of sine of u 1/2. I'm not missing anything, am I? I don't think so. I just have the integral there, and I have a half up front. Okay, 1/2 times cosine of log of 5t plus 6. Close that, and plus c. And that should be a minus sign, I think, because, yeah, it's a sine, so the cosine gets a minus sign. Okay, let's just see how it goes. Doesn't understand my answer again. Okay, I'm sorry. You're not happy with me. So maybe I should rethink about that. So it's log. No, I don't think. Yeah, I think that should be fine. I guess since it doesn't understand my answer, that's a problem. Oh, I think that's one too many parentheses. Now try it. Ah, there we go. Cool. All right, so now let's kick it up to the advanced level. All right, advanced. Here we go. Okay, 1 over 4t log of 3t to the 7th power. Again, let's just make a log of 3t as our u. Then du is equal to 1 over t dt. So I have a 1/4 outside. So I have a 1/4 integral 1 over log of u to the 7th power. So it's, or 1 over 7, yeah. So 1 u to the minus 7th power, right? So I'll integrate that. That's going to be u to the minus 6 over minus 6. Okay, u to the minus 6 over minus 6. And I have a 1 over 4 outside. So I have a minus 1 over 24 on the outside times, I feel like I have to be careful, log of 3t to the 6th? To the 6th power? Or, no, sorry, minus 6th power. Okay, maybe I should just write this as minus 1 over 24 log 3t, yeah, just to the minus 6th power, plus c. Correct, awesome. Okay, here we go, number 8. Oh, goodness. Integrate 3e tan inverse 3t, 9t squared. Okay, so, right, the derivative of tangent inverse is 1 over 1 plus x squared. Okay, that's helpful. So if I can let u is equal to tan inverse of 3t, right, then that's 1 over 3t squared plus 1. So 3t squared, that's 9t squared plus 1 times a factor of 3. Okay, so there's an extra factor of 3. I need to push it downstairs, so it's 3 over 12, 1/4. Okay. Wait a minute. It seems like it's just 1/4 times e to the tan. Okay, I don't know how to do this right. E to the, maybe I should just write this arctan 3t plus c. Is that right? I'm not so sure. So let me just do it one more time in my head. So we have a 3/4 on the outside. Just push it away. We have tan inverse 3t, 9t squared plus 1. Arctangent of 3t, derivative of that's 9t squared plus 1 times 3. So we'll divide it by 3 on both sides. So I get the factor that I need. So it should be just 1 over 4th. And I have e to the u, du, which is just e to the u, right? So go for it. Ah, good. Awesome. And now number 9. Compute 3/5 secant squared 2t log tan 2t dt. Okay, goodness. So what's going to help me out here? Ooh. What should I make my u? Because I have a secant squared, I have a tangent, derivative of... Ooh. This looks like a problem, because like secant and secant times secant. So I have 2 secants and I have a secant tan. No, that's not going to help. Okay, secant squared 2t log tan 2t. This is a tough one. Like, I am genuinely stumped right now. Oh my gosh. Sorry, I mean, like, this is actually something. It probably is easier than I am letting myself think, but I feel the pressure, guys. So apologies if I am not doing it properly. Log of tan 2t. What's the derivative of that? Log of tan 2t. That's 1 over tan 2t times the derivative of tan 2t. So that's secant squared 2t. Okay. That was dumb. So I have 3/5 on the outside log tan 2t. So I'll have 1 over tan 2t times, right, secant squared. Okay, so if log tan 2t, if the derivative of that is 1 over tan 2t times secant squared 2t. Oh, gosh. Oh, I can't help but feel that, like, okay, if I take the derivative of this, well, maybe I can work backwards here. Like, let's see, what function would I differentiate to get the integrand? The log of tangent 2t. It's just a substitution, Kyle. I feel like you're totally overthinking this. Oh my god. Okay, now I see what you have to do. You have to let u is equal to tan 2t, and then you'll have 2 secant squared 2t as your du. So push it downstairs. That would be 3 over 10. 3 over 10 log. Okay, then the log of tan 2t. Okay, so then you have 3 over 10, right, times... let me put a fraction here. Oh, snap. Don't open the source code. My bad. 3 over 10 times... what do we have here? So it's pretty much the log of u du. Okay, so then log of u du, that's u ln u minus u plus c, right? So I have to do times u, which is tan 2t, times ln of u ln u, tan 2t, minus u, tan 2t plus c. And then all of this needs to have the 3 over 10 multiply and stuff here. Right? I think that's it. Dang, after all that hard work. Okay, last one. Integral 10 in my head. Let's do it. Evaluate 5 sine 2t, 4 cosine 2t minus 6 squared plus 1. Just let u is equal to cosine 2t minus 6. Right, so I have 5 over 4, push that outside. Derivative of that is just going to be derivative of cosine's a negative sine, so I have a negative sine 2t, negative 2 sine 2t. So divide that by 2, so I have negative 5 over 8. So, okay, that's fine. Negative 5 over 8 is my prefactor. Negative 5 divided by 8 times, okay. Negative 5 over 8 times, I'm just getting u squared plus 1 in the denominator, right? Am I not going crazy here? That's u squared plus 1. So I have 1 over u squared plus 1 now, because my du is now covered. So that just becomes, well, the integral of 1 over u squared plus 1, which is just arctangent of u, right? Arctangent of cosine of 2t minus 6. Yeah, plus c. There we go. So there you have it, guys. 10 integrals for fun, all in my head. And that was fun practice. Very fun using substitutions. As you can see, I really like doing integrals. So hope you enjoyed this. This was just sort of showing you what Wolfram Alpha can do for you. And if you want to practice your integration skills, just go on to Wolfram Alpha. So thanks for watching.